Knowing whether you have malware inside your Linux machine is difficult. Using this tool, we can find out suspicious files dropped by attackers. In this video, we will learn how to use YARA to hunt for malware inside a Linux machine. YARA is a popular tool for researching malware samples. It can look through text or binary files. You can install it easily using your package manager. Invoking it from the command line is not complicated. You just need to pass a YARA rule. Then you can tell it to scan a directory or a file. To better understand this, let's do something. Let's say we have a file here that contains the following reverse shell payload. We will see how a YARA rule will detect this. Let's create our first rule. Then inside, we will create the following block that contains the actual rules. We will have 3 rule blocks, which are the meta, strings, and condition. Inside meta, we can put a description, then followed by an author and severity. The strings block will contain the actual patterns. Let's make a simple pattern for now. We will define a variable that will match makeFIFO command. Under the condition, we will tell YARA to look for files matching that pattern. To run it, we invoke YARA command and pass the rule we just prepared. Then we also want to pass the file containing the payload. Let's put -s so we can see the actual strings that match the pattern. As expected, our rule was able to match it. If we run it on a non-malicious file, nothing will be flagged. Going back to the match pattern, let's understand the output. At the top, we have the name of the rule in the file. This is the main way to identify what type of malware has been detected. So, naming your rules properly will give you better understanding of the detection. Below that are 3 columns separated by colons. The first one is offset from where the match was found. Hexadecimal A is 10 in decimal. This means the offset is located at the 10th byte. To better understand this, let's get the hex dump of the file. If we count from left to right and locate the 10th byte, the byte after that represents 6D, which is a hexadecimal representation of the character M. This exact location points to the start of makeFIFO command. The last 2 columns show us the variable that matches the pattern. Now let's say we have a directory containing scripts. One is malicious and the other one is legitimate. The good one also contains makeFIFO command, but it is used to back up a pipe. The second one is a malicious script dropped by an attacker, which contains same reverse shell payload. You might ask the question, if YARA only matches a pattern, then what's stopping us from just using Grep command? Well, let's try it to prove your point. If using Grep, we would normally do it like this. We will first do a recursive Grep for the string makeFIFO against the directory. It matches 2 files, which is not what we want. To remove the false positive, we will do another Grep to just include lines containing a shell and netcat command. So it looks like Grep can solve our problem. But what if the payload is broken down into several lines? If we run our Grep command, our detection mechanism no longer works. That's because Grep is line-oriented, meaning it can easily be bypassed by techniques such as when an attacker breaks down the payload into multiple parts. YARA, on the other hand, isn't line-oriented. It scans the entire file buffer. No matter how the attacker breaks down the payload, YARA will be able to discover it. This is only one advantage of YARA over Grep, and there are more, like being able to defeat obfuscation, faster scanning logic, the ability to give you file context, and so on. To solve those problems, I prepared a simple YARA rule that contains smart logic detection. After running it, aside from seeing only 1 hit, which is what we expected, it also gives us better context on the detection. So even if we break down the payload into multiple parts, YARA will still be able to see it. Now let's see what is inside this rule. This is very similar to the previous rule, but I just omitted the meta block for simplicity. So we only have the strings and condition block. Inside strings, we have different variables for the makeFIFO command, the shell, interactive option, and pattern we want to exclude. Under the condition, we tell YARA to look for patterns that contains makeFIFO that are associated with a shell, make sure they are interactive, and exclude anything that contains the admin token to prevent false positives. This is very simple logic, and it only scratches the surface of YARA's full potential. Now, what happens if the payload is obfuscated? Let's say we have a very long file with a hidden payload inside. Aside from hiding it in a large body of text, the attacker also base 64 encoded it. Using standard tools like Grep can make it very impossible to spot this. If we run a YARA rule that defeats obfuscation, we will catch it easily. Let's take a look at this rule. Inside strings block, we have a variable that doesn't only contain a pattern but also contains a special string at the end. This is a modifier. What it does is it tells YARA to look for base 64 encoded string for bin bash. This is a weak obfuscation technique from the attacker, so let's look for something harder to detect. Take a look at this file. Can you even spot the hidden payload? YARA can easily find that for us. Let's see the rule I used. What the attacker did is to convert bash into GDVM using X or obfuscation. That means we will also use a different modifier. The obfuscation is done by converting the original character into something different by applying an X or function using the hex 05 as the key. So what YARA does is loop through all possible key combinations and see what will match the pattern. This is another kind of modifier used for advanced detection. As we learned in this video, YARA is a very powerful tool for hunting malware. Using YARA allows us to spot malicious strings accurately. I hope you learned something today. If you find my content valuable, please support me by liking this video and subscribing to my channel. See you on the next one.